To build a complete humanoid robot, engineers must go through many different stages, starting with designing the basic structural frame. There is an old saying that appearance comes first. In robot manufacturing, the first step is creating the skeleton. Engineers use CAD design software to build a 3D model of the robot. This type of software is commonly used in engineering because it allows designers to create both 2D and 3D technical models while also simulating how different components will function once assembled. At this stage, engineers determine the robot's height, shoulder width, arm length, leg length, and overall body proportions so that the robot resembles a human as closely as possible. After that, the robot's body is divided into several separate modules, such as the head, chest, shoulder joints, spine, arms, and legs. Once the design is complete, these parts are manufactured using various methods. Some components are produced with 3D printing technology, while others that require greater strength are made from aluminum alloys or carbon fiber. These materials help keep the robot lightweight while still being durable. The next step is installing the movement joints. This stage is extremely important because it determines how flexible the robot's movements will be. Small rotating shafts, bearings, and hinges are installed at positions such as the shoulders, elbows, knees, and neck. Thanks to these joints, the robot can perform movements such as bending its arms, leaning forward, turning its head, or sitting down. Among all these parts, the spine and hip area are considered the most critical because they help the robot maintain balance when moving or lifting heavy objects. To improve stability, engineers often reinforce the internal structure with springs and support rods. After the entire frame is assembled, it undergoes a very strict inspection process. Each joint is carefully checked to ensure there are no structural deviations. The acceptable tolerance is usually around 0.1 millimeters. If the deviation exceeds this limit, the robot may have difficulty moving or even walking properly. In addition, many modern robots are equipped with force sensors inside their joints. These sensors allow the robot to detect when too much force is being applied. When that happens, the system automatically reduces the force to prevent mechanical damage. As a result, the robot can operate more safely and avoid potential failures during operation. Nếu bạn muốn, mình sẽ tiếp tục gửi part English, phần rất thú vị về robot skin made of silicone, eyes, cameras, and sensors, robot facial appearance and hair implantation. After the mechanical frame of the robot is completed, the next stage is often the most impressive one, creating a layer of artificial skin and a human-like face. If a robot only has a rigid metal structure, no matter how well it moves, it will still not feel truly human. That is why engineers spend a significant amount of time developing realistic artificial skin. This process usually begins by scanning a real human face using a high-precision 3D scanner. The device is capable of capturing even the smallest details, such as wrinkles around the eyes, the shape of the nose, or the contours of the lips. Once the data is collected, engineers convert it into a digital model. From this model, they create molds that will later be used to produce the robot's skin. These molds are typically made from hard plastic or specialized materials that can maintain a precise shape. When the mold is ready, liquid silicone is poured into it. The silicone used for robots is a special type that has a softness and elasticity similar to human skin. It is also resistant to heat, protected against ultraviolet light, and capable of maintaining its color over long periods of time. After the silicone hardens, the artificial skin is removed from the mold. Technicians then carefully trim away excess material and refine small details so the face looks more natural. Some modern robots are even equipped with artificial skin that contains ultra-thin pressure sensors. These sensors allow the robot to detect when someone touches it or when it is holding an object. This feature is especially important for robots designed to assist the elderly or help in medical environments. With these sensors, the robot can adjust the strength of its grip so it does not accidentally hurt a person. Once the skin is completed, engineers install the robot's eye system. The eyes of a robot are usually far more advanced than a simple camera. Most humanoid robots are equipped with several different types of sensors, including color cameras, infrared cameras, and depth sensors. This combination allows the robot to observe its environment with greater accuracy. For example, infrared cameras enable the robot to see even in low light conditions. Meanwhile, depth sensors allow it to estimate the distance between objects. Because of this, the robot can accurately determine where an object is located and reach out to grab it without missing. In addition to the eyes, robots are also equipped with directional microphones that can capture sound from multiple directions. This system allows the robot to recognize human speech while filtering out background noise. Some advanced robots can even distinguish between different voices and remember the voice of their owner. Once all the sensors are installed, the robot enters the final stage of its physical appearance. Specialists use extremely fine brushes to apply pigments to the skin, creating natural tones on the face. They may add blush to the cheeks, subtle shadows under the eyes, or even small freckles to make the robot look more realistic. The next step is attaching hair. Depending on the design, robots may use wigs or real hair strands that are implanted individually into the scalp. This process requires great precision and can take several days to complete. After all these steps, the robot begins to look almost human. When people touch the soft silicone skin, they often feel both amazed and slightly uneasy because of how realistic it feels. However, no matter how human a robot looks on the outside, it is still just a machine unless it has intelligence that allows it to think and respond. That is why the next stage is to create the robot's brain. Once a robot has a complete mechanical body, human-like skin, and a full set of sensors, the next critical step is giving it a brain that can process information and respond to the world around it. In reality, for a robot to communicate and perform tasks like a human, its intelligence system is usually divided into several layers. Each layer is responsible for a different function, ranging from motion control to information analysis and decision-making. The first layer is the motion control system. This part is responsible for controlling the robot's motors and mechanical joints. Engineers typically use programming languages such as Python, C++, or frameworks like the Robot Operating System to connect the software with servo motors and sensors throughout the robot's body. For example, when the robot's camera detects a person approaching, the visual data is sent to the central processor. The system then analyzes the distance and determines what action the robot should take. Depending on the situation, the robot might extend its hand for a handshake or greet the person standing in front of it. The second layer is the cognitive artificial intelligence system. This part enables the robot to understand language and interact with humans. Many modern robots are equipped with advanced AI models capable of natural language processing. Thanks to this technology, robots can understand questions from humans and provide appropriate responses. Some companies explain that their robots are not limited to pre-programmed answers. Instead, they are connected to powerful AI systems through the internet, allowing them to generate more flexible and dynamic responses. This capability allows robots to engage in more natural conversations and handle a wide range of communication situations. The third layer is the data learning system. This is one of the most important technologies that enables robots to become increasingly intelligent over time. Robots are trained by observing humans performing tasks in real-world environments. This data can be collected from videos or from sensors placed in workplaces and training facilities. After collecting the data, the robot learns to repeat those actions. If it performs a task incorrectly, the system adjusts the process and helps the robot improve in future attempts. This process is known as reinforcement learning, a method that allows robots to learn through trial, error, and correction. Because of this technology, many robots today can learn complex skills such as folding clothes, organizing objects, or assisting with manufacturing tasks in factories. In addition, modern robots are also capable of remembering user habits. For example, a household service robot may remember the daily schedule of its owner or certain routines within the home in order to provide better assistance. These personal data patterns are usually stored within the robot's memory system and are sometimes encrypted to protect user privacy. When all these systems work together, a robot is no longer just a moving machine. It becomes a system capable of observing, understanding, and interacting with humans in a much more natural way. After the robot's body, sensors, and artificial intelligence systems are fully developed, many humanoid robots today are already capable of performing real-world tasks. In several factories in China, robots are being trained to carry out different types of work, such as folding clothes, preparing simple meals, or transporting goods. Inside large industrial facilities, dozens of robots can operate continuously for many hours while practicing new skills. Every movement they make is recorded and analyzed in order to improve their performance. Some experts believe that in the future, robots will not only work alongside humans, but may even take part in the production of new robots. In other words, robots could eventually become part of the manufacturing lines that create their own kind. Today, many governments are investing heavily in humanoid robotics because they believe this technology will play a crucial role in the next industrial revolution. In China alone, investment in robotics and related technologies has grown rapidly in recent years. Some startup companies have even begun selling humanoid robots at much lower prices than before. Certain models are already being sold for around 88,000 Chinese yuan, which is roughly equivalent to a little over 12,000 US dollars. Meanwhile, more advanced robots, such as Tesla's Optimus, are expected to cost around 20,000 US dollars. The goal of many technology companies is to reduce production costs so that robots can be widely used across various industries. Robots are particularly useful for tasks that are dangerous, repetitive, or physically demanding for humans. For example, they can work in hazardous environments, carry heavy loads, or assist in caring for elderly people. However, as robotics and artificial intelligence continue to develop rapidly, many people have also started to worry about potential risks. Some experts believe that in the future, artificial intelligence may reach a level known as AGI, or Artificial General Intelligence. Unlike current AI systems that specialize in specific tasks, AGI would have the ability to learn and perform many different kinds of work, much like a human being. If such technology develops too quickly without proper oversight, it could lead to unpredictable consequences. In fact, there have already been incidents in factories where robots malfunctioned due to technical errors or control system failures. Events like these have led some people to question whether humans will always remain in control of the technologies they create. At the same time, many scientists emphasize that robots are fundamentally tools designed by humans. They do not possess real consciousness or genuine emotions like people do. Therefore, the greatest risk may not be robots themselves, but rather how humans choose to use this technology. In the future, robots may become a common presence in our daily lives. They could help humans work more efficiently, reduce dangerous labor, and provide assistance in many different fields. However, for this technology to develop in a positive direction, societies will need clear regulations and effective control systems. Only then can robots truly become tools that contribute to the progress and well-being of humanity. Bây giờ bạn đã có toàn bộ bản tiếng Anh hoàn chỉnh, Part 2, Part 5 cho video khoảng 18 đến 20 phút. Nếu bạn muốn, mình còn có thể giúp bạn thêm 3 thứ rất hữu ích cho kênh YouTube. Chỉnh lại toàn bộ script tiếng Anh thành bản narration cực mượt, chuẩn Voice AI Documentary Style. Chia câu chuẩn để tạo phụ đề SRT, English, Korean, Vietnamese. Viết lại hook mở đầu 30 giây cực thu hút để giữ người xem lâu hơn.